Moving on to first question. The angles of quadrilateral are in the ratio 3:5:9:13. Find the angles of the quadrilateral. Now moving on to solution. He has given the ratio of 4 angles of quadrilateral, that is 3:5:9:13. So here let us assume a quadrilateral ABCD. Then angle A, angle B, angle C and angle D will be the angles of quadrilateral. Let us assume that angle A is equal to 3x according to ratio, and angle B is equal to 5x, angle C is equal to 9x and angle D is equal to 13x. We know that sum of angles in the quadrilateral is equal to 360 degrees. We get here angle A plus angle B plus angle C plus angle D is equal to 360 degrees, which implies angle A is here 3x plus angle B is here 5x plus angle C is here 9x plus angle D is here 13x is equal to 360 degrees. That implies, let us take x common here, then we get in bracket 3 plus 5 plus 9 plus 13 is equal to 360 degrees, which implies 3 plus 5 is 8 and 8 plus 9 is 17 and 17 plus 13 is 30. So that will be 30x is equal to 360 degrees, which implies, now by transposing 30 to right hand side we get x is equal to 360 degrees by 30, and 30 goes in 360 12 times, so we got here x is equal to 12 degrees. Now as we got x is equal to 12 degrees, let us substitute in the angles ABCD. Then we get angle A is equal to 3x, which is equal to 3 into 12 degrees, nothing but 36 degrees, and angle B is here 5x, which is equal to 5 into 12 degrees, that is nothing but 60 degrees, and angle C is equal to 9x, which is nothing but 9 into 12 degrees, that is nothing but 108 degrees, and angle D is equal to 13x, which is equal to 13 into 12 degrees, that is 136 degrees. So finally we can say that angles of given quadrilateral are 36 degrees, 60 degrees, 108 degrees and 136 degrees. Moving on to the second question. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Now moving on to the solution. Let us note on the given information that diagonals of a parallelogram are equal. That means let us assume a parallelogram ABCD in which AC and BD will be the diagonals. He has given that AC is equal to BD, and now he asked us to prove that the given parallelogram ABCD is a rectangle. In order to prove that, let us follow a procedure. Now let us consider both the triangles, that is in triangle ABC and triangle BDA. Let us note down the similarities. AB will be equal to AB since it is a common side, and also AC is equal to BD since given that diagonals are equal. Here and also we get BC is equal to AD, as in parallelogram we know that two opposite parallel lines are equal. Now by triplets congruency we can say that triangle ABC is congruent to triangle BDA. Now as triangle ABC is congruent to triangle BDA, we can say when two triangles are congruent, then their corresponding angles and sides will be equal. So here we can equate angle ABC of triangle ABC equal to triangle BAD of triangle BDA. Let it be as equation number 1. Now let us assume that BC is parallel to AD and AB as transversal. Then here angle ABC and angle BAD lie on same side of transversal, and interiorly we know that sum of angles lying on same side of transversal is equal to 180 degrees. We can say angle ABC plus angle BAD is equal to 180 degrees. But from equation 1 we can say angle BAD is nothing but angle ABC. So that will be equal to 180 degrees, which implies 2 times angle ABC is equal to 180 degrees, which implies angle ABC is equal to 180 degrees by 2, and here 2 goes in 180 90 times. So finally we got angle ABC is equal to 90 degrees, which implies angle BAD is also equal to 90 degrees. So as two angles are equal to 90 degrees, here AB is perpendicular to AD and AB is also perpendicular to BC. So we can say the given parallelogram ABCD is rectangle, as we know that properties of rectangle that all the sides are perpendicular to each other and opposite sides are equal. As in parallelogram opposite sides are equal, and here we got the condition that every side is perpendicular to each other, we can say the given figure ABCD is a rectangle. Moving on to a third question. Show that if the diagonals of quadrilateral bisect each other at right angles, then it is a rhombus. Now moving on to solution. Let us note down the given information. He says that diagonals of a quadrilateral bisect each other at right angles. So let us consider a quadrilateral ABCD in which the diagonals AC and BD bisect each other perpendicularly at some O. So let us note down the given information that ABCD is a quadrilateral, and as AC bisects BD perpendicularly, we can say AO is equal to OC and also BO is equal to OD, and angle AOB is equal to angle COD is equal to angle BOC is equal to angle AOB is equal to 90 degrees. Here what we require to prove is ABCD is a rhombus. We know the properties of rhombus, that in rhombus the diagonals bisect each other perpendicularly and all the sides will be equal. Here initially the condition is given that diagonals bisect each other perpendicularly. In etc. we need to prove that all the sides are equal, that is AB is equal to BC is equal to CD is equal to DA. Now moving on to the proof. Now in order to prove this, let us consider two triangles, that is triangle COD and triangle AOB. In these two triangles we can say angle COD is equal to angle AOB is equal to 90 degrees, which is given, and he also given that OA is equal to OC or AO is equal to OC as diagonals bisect each other perpendicularly, and also we can say OB will be equal to OD from the given. From SAS property, as in triangle COD and triangle AOB, two sides and one angle is equal, we can say they both are congruent. So by SAS property of congruency, we can say triangle AOB is congruent to triangle COD, and we know that when two triangles are congruent, then their corresponding sides will be equal. So here the corresponding sides AB can be equated to CD. Now as we got AB is equal to CD, let us name it as equation number 1, and then now let us consider both the triangles, triangle AOD and triangle COD. In these two triangles, let us note down the similarities. Here angle AOD is equal to angle COD is equal to 90 degrees, we know that, and OD is equal to OD since it is a common side for both the triangles. OA is equal to OC as BD perpendicularly bisects OC, as BD perpendicularly bisects AC. So here one angle and two sides of the triangle AOD and COD are correspondingly equal, we can say triangle AOD is congruent to triangle COD. When two triangles are congruent, then their corresponding sides and corresponding angles can be equated. So here let us equate AD is equal to CD. Let us name it as equation number 2. Now let us consider triangle COD and triangle BOC. In this, angle COD is equal to angle BOC is equal to 90 degrees, and OC is equal to OC since it is a common side for both the triangles, and BO will be equal to DO as AC bisects BD perpendicularly. So here, as in two triangles, the corresponding angle and two corresponding sides are equal, we can say by SAS congruence rule, triangle COD is congruent to triangle BOC. Now when two triangles are congruent, we can say their corresponding sides and angles will be equal. So here the corresponding sides CD can be equated to BC. Let it name it as equation number 3. Now from 1, 2 and 3rd equations, we can say every side is equal to CD, and so we can say AB is equal to BC is equal to CD is equal to DA. Here initially from the given we know that diagonals of the quadrilateral bisect each other perpendicularly and all the sides are equal. So finally we can say that ABCD is a rhombus. That is what the proof required for us. Moving on to the 4th question. Show that diagonals of a square are equal and bisect each other at right angles. Now moving on to a solution. Let us note on the given information that he has given a square. So let us assume that a square ABCD, as ABCD is a square, we can say that all the sides in the square are equal. So here AB is equal to BC is equal to CD is equal to DA. Now we are required to prove that diagonals of the square are equal and bisect each other at right angles. Here the diagonals are AC and BD. So we are first required to prove that AC is equal to BD, and second thing They bisect each other at right angles, so we need to prove that. Let us assume that diagonals intersect at point O. Here we need to prove that AO is equal to OC and OB is equal to OD, and he says that they bisect each other perpendicularly. We have to prove that angle AOB is equal to angle BOC, angle BOC is equal to angle COD, and angle DOA or AOD is equal to 90 degrees. Now let us move on to the proof. Now in the proof, let us consider both the triangles, that is in triangle ABD and triangle ABC. AB will be equal to AB as it is a common side for both the triangles, and we can say AD is equal to BC as ABCD is a square, all the sides will be equal. And also finally we can say that angle BAD in triangle ABD is equal to angle ABC of triangle ABC, as in the square the sides are perpendicular to each other. So here in two triangles, one corresponding angle and two sides are equal. So by SAS congruence rule, we can say triangle ABD is congruent to triangle ABC. We know that when two triangles are congruent, then their corresponding sides and corresponding angles will be equal. Therefore, here we can equate the corresponding sides, that is AC is equal to BD. So this covers our first proof that diagonals of a square are equal. Now let us consider two triangles, that is triangle OAD and triangle OBC. In this, AD is equal to BC as all the sides of square are equal. Secondly, we can say that angle AOD and angle BOC are equal since they are vertically opposite angles about point O. And now let us consider that AD is parallel to BC and AC as transversal. Then angle DAO will be equal to angle OCB since they are alternate interior angles. Now again, considering the same point that AD is parallel to BC and BD as transversal, we can say angle ODA will be equal to angle OBC since they are also alternate interior angles. So now two corresponding angles and a side of triangles AOD and BOC are equal. So by ASA congruence rule, we can say triangle OAD is congruent to triangle OBC. So when two triangles are congruent, then we can say the corresponding angles and corresponding sides will be equal. So here we can equate OB is equal to OD and OA is equal to OC. As OB is equal to OD and OA is equal to OC, we can say AC and BD bisect each other. Now let us consider in triangle AOD and triangle AOB, OA will be equal to OA since it is a common side. We already proved that OB is equal to OD, and also we know that AB is equal to AD, as ABCD is a square. So here three corresponding sides of two triangles, that is AOD and AOB, are equal. So we can say that triangle AOD is congruent to triangle AOB. We know that when two triangles are congruent, then their corresponding angles and corresponding sides will be equal. So here we can equate the corresponding angles. Angle AOB is equal to angle AOD. Now if we observe clearly, angle AOB and angle AOD form linear pair about line BD. So we can say sum of angles on a linear pair, that is angle AOB plus angle AOD, will be equal to 180 degrees, which implies we know that AOB is equal to AOD. Let us replace it by AOD. Therefore we get angle AOB plus angle AOB is equal to 180 degrees. That implies 2 times angle AOB is equal to 180 degrees, which implies angle AOB is equal to 180 degrees by 2, which is nothing but 90 degrees. So here we got angle AOB is equal to angle AOD is equal to 90 degrees. Now if we observe, we got angle AOD is equal to angle BOC here. So let us name it as equation number 2. Therefore from equation 2 we can say angle AOB is equal to angle AOD is equal to angle BOC is equal to 90 degrees. Here we require to prove that another angle, that is angle COD, is also equal to 90 degrees. We know that sum of angles about point is equal to 360 degrees. We can say angle AOB plus angle BOC plus angle COD plus angle AOD or angle DAO is equal to 360 degrees, which implies here we have AOB, AOD and BOC as 90 degrees. So we can say 3 times 90 degrees, which is nothing but 270 degrees, plus angle COD is equal to 360 degrees. That implies angle COD is equal to 360 degrees minus 270 degrees, which is nothing but 90 degrees. So here also we got all the angles about point O is equal to 90 degrees. So we can say AC and BD bisect each other perpendicularly. This is what we are required to prove. Moving on to fifth question, show that if diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. Now moving on to solution. Let us note down the given information. He has given that diagonals of a quadrilateral are equal and bisect each other at right angles. So let us consider a quadrilateral ABCD in which the diagonals BD and AC intersect at O, and he says that bisect each other perpendicularly. So all these angles will be 90 degrees. So we can say AOB is equal to angle BOC is equal to angle COD is equal to angle DOA is equal to 90 degrees. And as the diagonals bisect each other perpendicularly, we can say OA is equal to OC and OB is equal to OD. And he also says that diagonals are equal. So we can say AC is equal to BD. Now we are required to prove that given ABCD is a square. Now let us move on to the proof. Now in the proof, let us consider the two triangles, that is in triangle AOD and triangle AOB, angle AOD is equal to angle AOB is equal to 90 degrees, since he has given that AC and BD bisect each other perpendicularly, and OA will be the common side for both the triangles, so that will be equal in both the triangles. Side OB will be equal to OD, since AC bisects BD at O, OB will be equal to OD. So we can say here the two corresponding sides and an angle are equal in both the triangles. Therefore, by SAS property of congruency, we can say triangle AOD is congruent to triangle AOB. We know that when two triangles are congruent, then their corresponding sides will be equal. So here we can equate AB is equal to AD. Here we got AB is equal to AD. Let us name it as equation number 1. Now let us consider the two triangles, that is in triangle AOB and triangle OBC. Angle AOB is equal to angle BOC, which is equal to 90 degrees, as we said that AC and BD bisect each other perpendicularly, and OA will be equal to OC, as BD is bisecting AC, and for both the triangles OB is the common side. So here two sides and the corresponding, here the two corresponding sides and an angle of the two triangles, triangle AOB and triangle BOC, are equal. Therefore, by SAS congruence rule, we can say triangle AOB is congruent to triangle BOC. And finally we can say from this, when two triangles are congruent, then their corresponding sides and corresponding angles will be equal. So therefore here the corresponding sides AB will be equal to BC. Let us name it as equation number 2. Then from equation 1 and 2 we get AB is equal to BC is equal to CD. Let us name it as equation number 3. Similarly, by considering triangle BOC and triangle COD and getting the congruence and applying the concept that two congruent triangles have corresponding sides equal and angles equal, we can say BC will be equal to CD. So finally we can say that AB is equal to BC is equal to CD is equal to DA. Therefore we got the first proof that all the sides are equal for the quadrilateral and diagonals bisect each other perpendicularly. So we can say ABCD is a rhombus. But if we consider in triangle AOD and triangle OAD, now let us clearly note on the figure that ABCD is a rhombus with AB is equal to BC is equal to CD, in which diagonals bisect each other perpendicularly at point O. Here he asked us to prove that ABCD is a square. We proved that ABCD is a rhombus. In order to prove that the rhombus is a square, we need to prove that all the angles, that is DAB and angle ABC and angle BCD and angle CDA is equal to 90 degrees. So in order to prove this, let us consider the two triangles, that is triangle ABC and triangle ABD. In triangle ABC and triangle ABD, let us note down the similarities, that is the both triangles are ABD, and let us see, that is triangle ABC. In these both triangles, AB is equal to AB since it is a common side, and AC is equal to BD since he has given that diagonals are equal, and also here BC is equal to AD as we got that ABCD is a rhombus. So the three corresponding sides in the two triangles are equal, therefore we can say that triangle ABC is congruent to triangle BAD. And we know that when two triangles are congruent, their corresponding angles and corresponding sides will be equal. Therefore we can say angle ABC is equal to angle BAD here, the corresponding angles. And we know that here AD will be parallel to BC as rhombus is a parallelogram in which all the sides are equal. Now by considering that AD is parallel to BC and AB as transversal, we know that sum of angles lying on the same side of transversal interiorly is equal to 180 degrees. We can say angle ABC plus angle BAD is equal to 180 degrees, which implies angle ABC plus angle BAD, we can replace it by angle ABC, which is equal to 180 degrees. That implies angle ABC plus angle ABC is nothing but 2 times angle ABC is equal to 180 degrees, which implies angle ABC is equal to 180 degrees by 2, which is equal to 90 degrees. So finally we can say that angle ABC is equal to angle BAD is equal to 90 degrees. Similarly, we can prove that angle BAC is equal to angle ADC is equal to 90 degrees by considering the triangles BAC and ADC. So here the angle between corresponding sides is 90 degrees. Here the angle between the adjacent sides is 90 degrees and all the sides are equal. So we can say that ABCD is a square. This is what the proof required for us. Moving on to the sixth problem. Diagonal AC of parallelogram ABCD bisects angle A. Then show that first thing, it bisects angle C also, and secondly ABCD is a rhombus. Now moving on to the solution. Now we are required to prove from the above figure details that AC bisects angle C. That means we need to prove that angle ACD is equal to angle BCA, and second thing, ABCD is a rhombus. In order to prove that given parallelogram is a rhombus, we need to prove that all the sides of the parallelogram are equal. That is AB is equal to BC is equal to CD is equal to DA. So let us move on to the proof. In order to prove this, let us consider two triangles, that is triangle ADC and triangle ABC. In both triangles, AC is equal to AC since it is a common side. In triangle ADC and triangle ABC, AC is equal to AC as it is a common side, and BC is equal to AD, as in the parallelogram opposite sides are parallel and are equal. Similarly, by applying the same concept that in parallelogram opposite sides are parallel and equal, we can say AB is equal to CD. Therefore, here the three corresponding sides of two triangles are equal. So by triplets property, we can say that triangle ADC is congruent to triangle CBA. So here, by applying the concept that when two triangles are congruent, then their corresponding angles will be equal. Here we can equate angle DAC is equal to angle BCA. So let it name is as equation number 2. Now, as triangle ACD is congruent to triangle BCA, we can say the corresponding angles are equal. So here angle CAD is equal to angle BCA, and also angle CAB is equal to angle DCA. Now we know that as AC bisects angle DAB, angle CAD is equal to angle CAB. So as we know that CAD is equal to CAB, we can equate angle BCA is equal to angle DCA, which implies this can be written as angle ACB is equal to angle ACD. So here angle C is divided by ACE equally. So we can say that AC bisects angle C. This is what our first proof required. And secondly, we came to know that as angle ACB is equal to ACD and angle CAD is equal to CAB, and we can equate angle CAD is equal to angle BCA is equal to angle DCA is equal to angle CAB. So now by considering angle CAD is equal to angle DCA, and by applying the concept that sides opposite to equal angles are equal, we can say AD is equal to BC, and by considering the other two angles, that is angle CAD is equal to angle BCA, and applying the same concept that sides opposite to opposite equal angles or equal, we can say AB is equal to BC, as angle CAD is equal to angle DCA. The sides opposite to these angles are equal, which implies AD is equal to CD. Here in the parallelogram, the non-parallel sides are equal, so we can say that ABCD is a rhombus. This is for the required second proof. Moving on to 7th question. ABCD is a rhombus. Show that diagonal AC bisects angle A as well as angle C, and diagonal BD bisects angle B as well as angle D. Now moving on to the solution. He has given that ABCD is a rhombus. So let us assume that ABCD is a rhombus. We know the properties of a rhombus as all the sides will be equal, that is AB is equal to BC is equal to CD is equal to DA, and diagonals bisect each other perpendicularly. So here the diagonals are AC, which will be perpendicular to BD. Now we are required to prove that firstly AC bisects angle A and angle C, and secondly BD bisects angle B and angle D. Now in order to prove this, let us follow procedure. Let us consider the rhombus ABCD, and initially let us assume that only AC as diagonal. So we consider ABCD is a rhombus and AC as diagonal. Now here if we observe, the rhombus is clearly divided into two triangles, that is triangle ADC and triangle ABC. Here in these both triangles, DA is equal to AB, as all sides in the rhombus will be equal, and DC or CD can be equated to BC, and here AC is common side for both the triangles. So here by triplets property, as three sides correspondingly in the two triangles are equal, we can say triangle ADC is congruent to triangle ABC. We know when two triangles are congruent, then the corresponding sides and corresponding angles will be equal. So here the corresponding angle DAC can be equated to triangle CAB, and also angle DCA can be equated to angle ACB. Here if we observe clearly, as angle DAC, here if we observe clearly, angle DAC is equal to angle CAB and angle DCA is equal to angle ACB. We can say that AC is bisecting angle A and angle C. Now this is what our first proof required. Now in order to prove the second proof, that is BD bisects angle B and D respectively, let us consider the same rhombus ABCD, this time with BD as diagonal. Then we can say in both the triangles, that is triangle DAB and triangle DCB, AD is equal to CD and AB will be equal to BC. And here if we observe, BD is common side for both the triangles. So here, as three corresponding sides in both the triangles are equal, by triplets property we can say triangle DAB is congruent to triangle DCB. We know when two triangles are congruent, then their corresponding angles and corresponding sides can be equated. So here in triangle ADB, angle ADB can be equated to angle CDB. And also angle ABD can be equated to angle DBC. So here, as these two angles are equal, as angle ADB is equal to angle BDC and angle ABD is equal to angle DBC, we can say that BD is bisecting angle B and angle D. This is what our second subpart proof. Moving on to the 8th question. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. Show that ABCD is a square, and secondly, diagonal BD bisects angle B as well as angle D. Now moving on to the solution. He has given that ABCD is a rectangle. So let us assume the rectangle ABCD according to the problem. We know the properties of rectangle as lengths will be equal and the breadths will be equal. Two opposite sides will be equal, that means. He also says that diagonal AC bisects angle A as well as angle C. So he has given that AC bisects angle A as well as angle C. So here, if we consider angle A, angle DAB will be equal to, here if we consider angle A, here angle DAC will be equal to angle CAB, as AC is bisecting angle A, and also AC is also bisecting angle C, so we can say angle DCA is equal to angle ACB. Now he asked us to prove that first thing, ABCD is a square and secondly BD bisects angle B as well as angle D. So now in order to prove this, let us follow a procedure. Now in triangles DAC and triangle CAB, if we observe angle DAC is equal to angle CAB and angle DCA is equal to angle ACB, since it is given that AC bisects angle A and angle C, and in these two triangles AC is equal to AC, which is common side for both the triangles. So here the two corresponding angles and a side in both the triangles are equal. So here we can say according to ASA property, triangle DAC is congruent to triangle BAC. So here, as two triangles are congruent, we can say the corresponding sides and corresponding angles will be equal. Therefore, the corresponding side of DA in triangle ABC is, or BAC is, AB. So here AD can be equated to AB and DC can also be equated to BC, which are corresponding sides. So here initially we know that AB is equal to CD and BC is equal to AD. So here we can say from these four relations all the sides are equal, that is AB is equal to BC is equal to CD is equal to DA. So here the given rectangle will be a square. Therefore we can say ABCD is a square. This is what our first subpart of the proof required. Here we proved that ABCD is a square. He asked us to prove in the second subpart of the proof that BD bisects angle B as well as angle D. So here we are required to prove that angle ABD is equal to angle DBC and angle CDB is equal to angle ADB. So in order to prove that, let us consider both the triangles, that is triangle ABD and triangle BDC. In these both triangles, as he has given ABCD is, as we have proved that ABCD is a square, in these both triangles AD will be equal to BC and also AB is equal to CD. Now as it is a square, we can say angle DAB is equal to angle DCB is equal to 90 degrees. As in square, the adjacent sides are perpendicular. Now the two corresponding sides and the corresponding angle in both the triangles is equal. We can say triangle ABD is congruent to triangle CBD. Now as two triangles are congruent, we can say the corresponding angles and corresponding sides can be equated. So here angle ADB is equated to angle BDC and also angle CBD is equal to angle DBA. Here as these angles are equal, we can say BD bisects angle B and angle D. This is what our second subpart of the proof required.